The morning of August 17th, 1943, Sicily. In a dusty motor pool outside the newly captured town of Messina, 3 Italian engineers stood around a battered American Jeep, their faces registering something between professional fascination and profound disbelief. The vehicle had been abandoned by retreating Allied forces just hours earlier, one of dozens left behind in the chaotic final days of the Sicilian campaign. Its olive-drab paint was scoured by desert sand, the canvas top torn, the windshield folded flat against the hood. But it was running. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Captain Giuseppe Morandi, a mechanical engineer who'd spent the previous 3 years designing improvements for Fiat's military truck line, circled the Jeep slowly. He'd examined captured British equipment before. Crusader tanks with their Christie suspension, Bren carriers with their complex track systems. Each time, he'd found sophisticated engineering solutions, expensive materials, careful craftsmanship. This American machine looked like someone had welded together the simplest possible components and called it finished. 4-leaf springs, Morandi said, crouching beside the front axle. Semi-elliptical. No independent suspension. No torsion bars. Nothing we haven't been using since 1920. His colleague, Lieutenant Marco Benedetti from the Ansaldo tank works in Genoa, knelt beside him. The whole chassis is just a ladder frame, 2 parallel rails with crossmembers. I've seen agricultural tractors with more sophisticated structures. The third man, Sergeant Paolo Ricci, a field mechanic who'd kept Italian vehicles running through 3 years of desert warfare, stood with his arms crossed. "May I drive it, sir?" Morandi nodded. Ricci climbed behind the wheel, pressed the floor-mounted starter button, and the 4-cylinder engine caught immediately. He drove the Jeep in a slow circle around the motor pool, then accelerated toward a section of broken ground where German engineers had blown the roadbed during their retreat. Chunks of asphalt and stone created obstacles that Italian trucks carefully avoided. The Jeep went straight through them. Not around them. Not slowly picking a path. Straight through, at speed, bouncing over rocks the size of footballs, the suspension compressing and rebounding with what looked like impossible flexibility. Ricci steered one-handed, the other braced against the windshield frame. When he stopped and climbed out, his expression had changed. "Madonna," he said quietly. "Captains, you need to drive this yourself." What followed over the next 6 hours would fundamentally challenge everything these Italian engineers thought they understood about military vehicle design. The Jeep weighed just over 2,400 pounds. Their standard light truck, the Fiat Spa 38R, weighed 6,400 pounds empty. The Jeep had 60 horsepower. The SPA 38R had only slightly more. On paper, they were comparable vehicles. On the mountain roads above Messina, they weren't even in the same category. The story of how Italian engineers confronted American automotive philosophy through this single captured vehicle reveals more than just technical specifications. It exposes a fundamental difference in engineering cultures, manufacturing priorities, and military doctrines that would help determine the outcome of the war. The Jeep represented something the Italian engineering establishment had never seriously considered: the possibility that simpler could actually be better, that standardization could defeat craftsmanship, and that designing for mass production might matter more than designing for performance. To understand why this realization shocked Italian engineers so completely, you have to understand the world they came from: Italian, military. Vehicle development in the 1930s and early 40s existed in a strange space between pride and limitation. Italy had legitimate automotive expertise: Fiat, Lancia, Ansaldo, OM. These companies had produced innovative civilian vehicles, won racing championships, pioneered diesel engines for military use. Italian engineers understood suspension geometry, metallurgy, power-to-weight ratios, but they designed for an industrial base that couldn't support what they created. The SPA 38R light truck that formed the backbone of Italian military transport was actually a well-designed machine. Introduced in 1935, it used a Fiat Type 18R 4-cylinder water-cooled engine producing 52 horsepower. The suspension consisted of 4 semi-elliptical leaf springs, similar to the Jeep. It had a 4-speed transmission with differential lock controlled from the dashboard, hollow rim wheels with oversized tires. Ground clearance was reasonable. The cargo bay could carry 25 soldiers or 2.5 tons of supplies. In Libya and East Africa during the late 1930s, the SPA-38R proved sturdy and reliable. Italian commanders praised it. French military observers were impressed enough that France ordered 500 units in the spring of 1940, with 400 delivered before Italy entered the war. Over 17,000 SPA-38Rs would be produced between 1936 and 1948, making it Italy's most numerous military vehicle. So why did Captain Morandi, an engineer who'd worked on SPA-38R improvements, stare at the captured Jeep with something approaching despair? The answer lay not in the basic design, but in what that design represented about the manufacturing philosophy behind it. The SPA-38R was built the way Italian vehicles had always been built, by skilled craftsmen, in relatively small batches, with significant hand-fitting of components. The chassis was assembled at the SPA works in Turin. Fiat supplied the engines from a separate facility. Magneti Marelli provided the electrical components from their plant in Milan. Bodies came from coach builders like Viberti or Orlandi, who typically produced luxury car bodies in peacetime. Each supplier maintained its own standards, its own tolerances, its own specifications. When a SPA-38R arrived at a motor pool for repairs, mechanics quickly learned that parts from one vehicle didn't necessarily fit another vehicle, even if both came off the same production line in the same month. Springs had to be measured, axle housings had to be checked, electrical connectors might not match. This wasn't incompetence. This was traditional European manufacturing, where skilled workers were expected to adjust and adapt components during assembly. It worked fine when you were producing 500 trucks per year, distributed across multiple factories, with experienced mechanics who understood the variations. It became a nightmare when you needed 5,000 trucks, delivered immediately, maintained by conscripted soldiers with minimal training, operating hundreds of miles from the nearest depot. The Jeep represented the opposite philosophy. Everything about its design prioritized interchangeability and rapid production. Morandi discovered this when he and Benedetti began taking measurements. The leaf springs front and rear were identical in length and mounting points, differing only in spring rate. This meant a single spring design could be manufactured in vast quantities, with the difference between front and rear accomplished by adding or removing leaves from the pack. The axles were identical units, using the same differential, the same wheel bearings, the same brake drums. Front and rear axles could literally be swapped if necessary. The frame rails were simple channel section steel, punched with standardized holes for crossmember bolts. No welding required for basic assembly. No jigs needed to maintain alignment. 2 rails, 8 crossmembers, bolt them together with standard hardware, done. The body panels were stamped steel, flat, or with simple curves that didn't require expensive dies or skilled metalworkers. The famous vertical slat grille was stamped from a single sheet of metal with 9 slots. Then Ford changed it to 7 to avoid patent issues. Either way, it took seconds to produce on a power press. When Morandi examined the engine, a Willys L134 Go Devil 4-cylinder flathead, he found the same philosophy. Conventional design, simple casting, side valves that a minimally trained mechanic could adjust with basic tools, no overhead cams, no complicated valve trains. The carburetor was a basic single-barrel design. The electrical system was 6-volt, using readily available components. Oil bath, air cleaner, mechanical fuel pump, everything designed so that replacement parts could be manufactured by multiple suppliers and installed by soldiers who'd been civilians 90 days earlier. This was what stunned Morandi. Not that the Jeep was technically sophisticated, it wasn't, but that it was brilliantly optimized for a type of warfare Italy had never seriously prepared for. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Industrial-scale attrition, where replacement vehicles mattered more than individual vehicle quality. The suspension system demonstrated this philosophy in miniature. Each Jeep leaf spring consisted of multiple leaves of spring steel held together with a center bolt and clips. Simple, ancient technology, but the leaves were carefully graded in length and thickness to provide progressive spring rates. When the suspension compressed under light loads, only the main leaves deflected. As loads increased, shorter leaves came into contact, stiffening the spring. This gave the Jeep a relatively comfortable ride when lightly loaded, while preventing bottoming out when heavily loaded or traversing obstacles. Italian vehicles used similar progressive leaf springs. The difference was in manufacturing. Italian springs were typically custom-matched to specific vehicles during assembly, with workers selecting leaves that would provide the desired characteristics. American springs were manufactured to tight tolerances from standardized steel stock, then assembled in predetermined configurations. Every Jeep got the same springs. Every spring pack had the same number of leaves, the same thickness, the same heat treatment. This meant that when a spring broke in the field, and springs did break, constantly, on both American and Italian vehicles, the American mechanic could pull a replacement from depot stock with confidence that it would fit and perform identically to the original. The Italian mechanic had to measure the broken spring, check its specifications, hope that a compatible replacement was available, and possibly adjust other components to compensate for minor variations. Multiply this parts interchangeability advantage across every component of the vehicle, and you begin to understand why the Jeep could be produced at scales Italian industry couldn't match. Between 1941 and 1945, American factories produced approximately 640,000 Jeeps. That's more than the total number of all trucks produced by Italian industry during the same period, for all purposes, military and civilian combined. Willys and Ford together built more Jeeps in a single month of 1943 than Italy produced SPA 38Rs in an entire year. But the production numbers only hint at the real advantage. The Jeep's design meant that multiple factories could produce identical vehicles without detailed coordination. Willys made the design. Ford licensed it. Both companies produced vehicles that were completely interchangeable down to individual bolts. A water pump from a Ford-built GPW fit perfectly on a Willys-built MB. Springs, axles, transmissions, steering components, all identical, all interchangeable. Italian industry couldn't achieve this level of standardization. When Fiat-controlled SPA wanted to license the SPA 38R design to another manufacturer to increase production, they discovered that the design required specialized machine tools, specific supplier relationships, and experienced workers who understood the acceptable ranges of variation in components. You couldn't just hand the blueprints to a different factory and expect comparable output. This was the fundamental insight that troubled Morandi and Benedetti as they examined the captured Jeep on that August morning in Messina. They were looking at a vehicle that was technically inferior to Italian designs in multiple ways: less sophisticated suspension, older engine technology, crude manufacturing techniques, but strategically superior in the only way that mattered. It could be built in numbers that made individual technical superiority irrelevant. When Sergeant Ricci drove the Jeep up a steep fire road that switchbacked up the mountains above Messina, the vehicle's tactical advantages became impossible to ignore. The Jeep's wheelbase was just 80 inches. Its turning radius was tiny. On narrow mountain roads where larger vehicles had to carefully negotiate hairpin turns, sometimes requiring multiple backing and filling maneuvers, the Jeep simply spun around. Ground clearance of 8 3/4 inches, combined with minimal front and rear overhang, meant the Jeep could drive over obstacles that would high-center larger trucks. But it was the suspension articulation that really demonstrated the American vehicle's off-road superiority. When one wheel encountered a rock or crater, that wheel could compress or extend dramatically, while the other three maintained contact with the ground. The simple leaf springs, mounted on solid axles, allowed this movement without complex linkages or control arms. The relatively short wheelbase meant that when the front wheel climbed an obstacle, the rear wheel could drop into a depression, with the chassis twisting to accommodate the terrain. Italian vehicles, including the SPA 38R, used similar basic suspension layouts. The difference was in execution. Italian springs were typically stiffer to support heavier vehicle weight. Longer wheelbases provided more stable highway ride, but reduced ability to follow rough terrain contours. Larger vehicles offered more payload capacity, but needed more careful route selection. The Jeep was optimized for exactly the opposite priorities. It sacrificed payload for mobility, sacrificed highway comfort for rough terrain capability, sacrificed craftsmanship for producibility. And in the specific conditions of World War II warfare, where maintaining supply lines through destroyed infrastructure mattered more than maximizing individual truck capacity, these trade-offs proved correct. Morandi drafted a detailed report that evening, working by candlelight in a requisitioned villa. He documented everything: dimensions, weight distributions, material thicknesses, component counts. He sketched the suspension geometry, measured spring rates, examined welding techniques. His conclusion was careful, professional, and damning. The American Light Reconnaissance Vehicle demonstrates crude but effective design principles, prioritizing mass production over individual performance. Suspension system utilizes conventional components with exceptional manufacturing standardization, allowing production rates impossible for Italian industry to match. Recommend immediate study of manufacturing philosophy rather than technical specifications. That report would never reach Rome. Within weeks, the Italian government would collapse, the armistice would be signed, and Italy would splinter into German-occupied North and Allied-occupied South. Morandi's detailed observations of American industrial philosophy would be filed away, ultimately lost in the chaos. But the lessons he learned that day, examining a vehicle that looked primitive but performed extraordinarily, recognizing that manufacturing philosophy could matter more than engineering sophistication, those lessons would eventually transform Italian automotive design in the decades after the war. To truly understand what Italian engineers saw when they examined that captured Jeep in August 1943, we need to step back and look at how American military vehicle development had evolved in the previous 3 years. Because the Jeep wasn't just a product of American industrial capacity, it was the result of a radically compressed development timeline that forced American engineers to abandon every traditional assumption about how military vehicles should be designed. July 11, 1940, the U.S. Army Quartermaster Corps issued specifications for a quarter-ton four-wheel drive reconnaissance vehicle. The requirements were extraordinarily demanding. Wheelbase no more than 75 inches, weight under 1,300 pounds, capable of carrying a 660-pound payload, powered by an engine producing 85 foot-pounds of torque. Fold-down windshield for minimal profile, blackout lighting, 3 bucket seats, four-wheel drive with 2-speed transfer case. And companies had exactly 49 days to deliver a working prototype. 49 days. To design, engineer, source components, build, and test a completely new military vehicle. Traditional European military procurement processes took years. Italian tank development programs typically ran 3 to 5 years from initial specification to production. The Americans were demanding a revolutionary vehicle in 7 weeks. Of the 135 American automotive manufacturers contacted, only 3 responded. American Bantam Car Company, Willys Overland, and Ford. Bantam was smallest, but they were desperate for work and committed to the impossible timeline. Their chief engineer, Harold Christ, brought in freelance designer Karl Probst on July 17, 1940. Probst produced the initial design in just 2 days. 2 days. For a complete military vehicle design that would eventually become the most produced combat vehicle in history, the design that emerged, the Bantam reconnaissance car, later refined by Willys and Ford into the standardized MB and GPW models, represented something fundamentally different from traditional military vehicle development. Probst and his colleagues didn't have time for sophisticated engineering solutions. They used whatever components were readily available: Ford Model A steering gears, Spicer axles from existing trucks, simple ladder frames, conventional leaf springs. The genius wasn't in innovation. The genius was in recognizing that a combination of readily available components, optimized for rapid production, could create a vehicle more useful than anything designed through traditional methods. This philosophy would have been alien to Italian military vehicle designers. When Ansaldo and Fiat collaborated on new tank designs, they started with performance requirements and engineered solutions to meet them. The M1340 medium tank, introduced in 1940, used a diesel engine because diesels offered better fuel efficiency and reduced fire risk. It used riveted armor because Italian industry had more experience with riveting than welding. It mounted the gun in a fully traversing turret because that provided tactical flexibility. Each decision was technically sound. Each made sense within Italian engineering culture. But the accumulation of these individually sensible decisions created a tank that was expensive to produce, difficult to maintain, and impossible to manufacture in quantities that matched battlefield losses. The Americans, working under impossible time pressure, accidentally discovered a better approach: design. For manufacturing first, performance second. The Jeep's suspension wasn't sophisticated, because sophisticated solutions required custom components and skilled assembly workers. Simple leaf springs could be stamped from sheet steel by any factory with basic metalworking equipment. The engine wasn't advanced, because advanced designs required specialized machine tools and experienced machinists. The Go Devil 4-cylinder used technology from the 1920s, specifically because it could be built quickly by workers with minimal training. When Lieutenant Benedetti examined the Jeep's rear axle assembly on that morning in Messina, he found this philosophy expressed in mechanical form. The axle housing was a simple tube with a differential housing welded in the center. The springs mounted directly to the housing with U-bolts, shock absorbers attached with basic brackets. The entire assembly could be removed by loosening perhaps 24 bolts. No special tools required, no alignment procedures, no calibration, just basic hand tools and mechanical aptitude. Compare this to the rear axle on an Italian M1340 tank: complex suspension arms connected to torsion bars inside the hull, specialized bearings requiring precise clearances, multiple adjustment points that needed to be carefully set during assembly. When this suspension worked properly, it provided excellent ride characteristics and good off-road performance. When it broke, and it broke frequently in North African conditions, it required specialized tools, experienced mechanics, and often components that weren't available in forward depots. The Jeep's suspension might have been crude, but it was crude in a way that frontline soldiers could actually repair. This was revolutionary thinking for Italian engineers, trained in pre-war European manufacturing traditions, where vehicles were expected to return to depot facilities for major repairs. Sergeant Ricci, the mechanic who'd kept Italian vehicles, running through 3 years of desert warfare, understood this instinctively. After driving the captured Jeep for several hours, he asked Captain Morandi a simple question. "Sir, how long would it take to replace the front axle on this vehicle with basic tools?" Morandi thought about it. On an SPA 38R truck, axle replacement was a depot-level repair requiring jacks, specialized pullers, alignment fixtures, 6 to 8 hours minimum with proper equipment and experienced mechanics. "Try it," Morandi said. Ricci gathered 2 soldiers and basic hand tools. They jacked up the Jeep, disconnected the steering linkage, removed the shock absorbers, unbolted the spring U-bolts, and pulled the entire front axle assembly free in 45 minutes. Installing a replacement axle, had they had one, would have taken about the same time. No alignment needed because the leaf springs automatically positioned the axle correctly when torqued to specification. No special tools needed because everything used standard bolt sizes. This was the kind of engineering insight that didn't show up in specification sheets, but determined whether armies could maintain mobile operations. A vehicle that soldiers could repair quickly with limited tools was infinitely more valuable than a vehicle that required specialized facilities and trained technicians, regardless of which vehicle had superior technical specifications. Italian military logistics were based on the European model. Maintain extensive depot facilities behind the lines where specialized workers performed major repairs. Keep spare parts inventories at these depots. Design vehicles that would last between major maintenance intervals. This worked acceptably in Europe, where rail networks could move vehicles between front lines and depots, where civilian industry could supplement military facilities, where maintenance schedules could be reasonably predicted. It collapsed completely in North Africa. The Italian logistical system in Libya and Egypt was already strained by 1941. Limited port capacity at Tripoli and Benghazi meant supplies arrived slowly. British naval interdiction meant ship losses were high. Vast distances meant vehicles spent days driving between depots and front lines. Harsh desert conditions, sand in every mechanism, extreme temperature swings, limited water for cooling systems meant breakdown rates exceeded any planning assumptions. When an Italian truck broke down in the desert, the standard procedure was to attempt field repairs. If those failed, tow the vehicle to the nearest depot if possible, or abandon it if not. Depot facilities attempted repairs, but were constantly short of parts, tools, and experienced workers. Vehicles queued for weeks waiting for components. Many were eventually cannibalized to keep other vehicles running. The Americans solved this problem through brutal simplicity. Build so many vehicles that you could afford to replace rather than repair. Design those vehicles so that even major component failures could be fixed by frontline mechanics. Stockpile standardized parts in quantities that assumed replacement rather than rebuilding. This philosophy would have seemed wasteful to Italian engineers. Why design vehicles to be thrown away when skilled mechanics could rebuild them? Why stockpile entire axle assemblies when individual bearings and seals could be replaced? Why use standardized components when custom solutions could optimize performance? The answer: because in modern industrial warfare, tactical mobility trumped economic efficiency. An army that could keep 70% of its vehicles running with crude field repairs would defeat an army that could eventually restore 90% of its vehicles through expert depot rebuilding, because eventually didn't matter when battles were measured in days, not months. Captain Morandi's report touched on this, but couldn't fully articulate it because the concept was so foreign to Italian military thinking. He wrote, "American vehicle design appears to prioritize ease of field maintenance over operational lifespan. Components are oversized and simplified, suggesting expectation of replacement rather than repair. Manufacturing tolerances are loose by Italian standards but appear adequate for intended service life." What he was observing, without quite understanding it, was planned obsolescence applied to military equipment. The Jeep wasn't designed to last 20 years like a well-maintained civilian vehicle. It was designed to last 2 years of hard combat use, then be replaced by new production. This was economically rational only for a nation with industrial capacity so vast that vehicle replacement was cheaper than extensive field repair infrastructure. Italy didn't have that capacity. Italian vehicle production, in 1943, totaled roughly 5,000 units across all types: trucks, cars, armored vehicles, everything. American Jeep production alone exceeded 50,000 vehicles that same year. When you could build vehicles 10 times faster than your opponent, you could afford to design them as semi-disposable. When your production was limited, you had to design for longevity and repairability, which meant complexity, which meant specialized maintenance, which meant logistical vulnerability. This was the trap Italian military engineering had fallen into. Every technically sound decision: use advanced diesel engines for better fuel economy, employ sophisticated suspension for better ride quality, build strong chassis for long service life, contributed to a logistics system that couldn't sustain mobile warfare against an opponent with different priorities. The suspension system exemplified this. When Benedetti measured the Jeep's leaf springs, he found they were thicker and used more leaves than strictly necessary for the vehicle's weight. Overbuilt, he noted in his own report. Springs could be lightened by at least 15% without compromising function. He was correct technically, but he was missing the strategic logic. Those extra leaves meant the springs could withstand more abuse before breaking. When they did break, the additional leaves provided redundancy. The spring would continue functioning, albeit with degraded performance, allowing the vehicle to drive itself to a maintenance point. And when replacement was necessary, the standardized overbuilt springs could be manufactured with looser tolerances, meaning more factories could produce them without specialized equipment. Italian springs were engineered to exact specifications, then carefully matched during vehicle assembly. American springs were engineered to be good enough across a wide range of loads and conditions, then mass-produced without individual fitting. The American approach was less elegant from an engineering perspective. It was vastly superior from a warfighting perspective. The same logic applied to the Jeep's engine. The Go Devil four-cylinder produced 60 horsepower from 134 cubic inches displacement. This was mediocre performance for the era. Contemporary Italian engines achieved similar power from smaller displacement using more sophisticated designs, but the Go Devil used side valves, simple carburation, and conventional ignition. Every component was oversized and overbuilt. Connecting rods were thicker than necessary. Main bearings had more surface area than required. The cooling system had more capacity than needed. This meant the engine could operate reliably under conditions that would destroy a more highly tuned design. Contaminated fuel? The simple carburetor could handle it. Missed oil changes? The oversized bearings provided some margin. Overheating from blocked radiator? The excessive cooling capacity bought time. And when the engine finally failed, the entire power unit could be swapped in hours rather than attempting in-place rebuilding. Italian tank engines represented the opposite philosophy. The Fiat SPA diesel engines, used in M1340 and M1441 tanks, were sophisticated designs offering excellent fuel economy and power density. They were also sensitive to maintenance, requiring regular service, clean fuel, proper oil grades. In depot conditions, with trained mechanics and proper supplies, they were reliable. In field conditions with minimal maintenance and contaminated supplies, they broke down frequently. When those diesel engines failed, field repair was nearly impossible. The engines had to be removed from the vehicle, transported to depot facilities, disassembled by skilled workers, rebuilt with proper components, tested, then reinstalled. This process took weeks when parts were available, months when they weren't. Italian tank units in North Africa frequently had higher percentages of tanks deadlined for mechanical issues than for battle damage. American tank units faced similar mechanical challenges, but could often resolve them faster because Sherman tank engines were designed for replacement rather than rebuilding. The Continental radial aircraft engines used in many Shermans could be pulled and replaced with depot stock in a day. Field mechanics didn't rebuild failed engines, they swapped them for refurbished units from supply stocks. This kept more tanks operational but required enormous logistics infrastructure. Italy couldn't build that infrastructure. Limited shipping capacity, long supply lines, small industrial base. These realities meant Italian forces had to make do with whatever vehicles and parts actually reached the front. This drove Italian engineers towards sophisticated designs that maximized performance from limited numbers, when they should have been designing simpler vehicles that could be produced and supported in larger quantities. The Jeep represented the solution to a different problem. How do you motorize an army when you have unlimited industrial capacity but need to do it quickly? The answer: standardize ruthlessly, simplify aggressively, mass-produce relentlessly. Accept inferior individual performance in exchange for overwhelming numerical superiority and supportability. This approach worked because America had the industrial capacity to sustain it. By mid-1943, American factories were producing approximately 2,000 Jeeps per month. That's more than the total number of all military vehicles Italy produced in an average month. When American units lost Jeeps to combat damage, mechanical failure, or simple accidents, replacements arrived within days or weeks. When Italian units lost vehicles, replacements might arrive in months or never. Morandi's report concluded with a recommendation that Italian military vehicle development should study American manufacturing philosophy. But by the time he wrote those words, the war was already lost for Italy. The industrial capacity that made the Jeep possible, the vast steel mills, the automotive factories, the machine tool producers, the rubber plants, the electrical component manufacturers couldn't be wished into existence. Italy's industry had been shaped by decades of protectionism, limited domestic markets, and craft manufacturing traditions. Transforming that industrial base would require years of investment and restructuring. The Jeep's suspension, examined in detail by 3 Italian engineers in a dusty Sicilian motor pool, told a story about industrial warfare that Italy had learned too late. Sophisticated engineering couldn't overcome manufacturing limitations. Technical excellence didn't matter if you couldn't produce vehicles in numbers that sustained combat operations. Individual superiority was meaningless when confronting mass production backed by intercontinental logistics. When Allied forces landed at Salerno on September 9, 1943, they brought thousands of jeeps ashore in the first waves. Jeeps carried commanders to forward positions, jeeps towed anti-tank guns, jeeps evacuated wounded, jeeps maintained communication between dispersed units. The small, crude, simple vehicles enabled the tactical mobility that modern amphibious warfare required. Italian forces, now fighting alongside Germans or reorganizing under Allied control, watched this deployment with professional understanding. They'd seen the same vehicles in Sicily, North Africa, and now mainland Italy. They understood what the jeeps represented, an industrial capacity so vast that quarter-ton vehicles could be treated as disposable, a logistics system so efficient that complex parts could be delivered to forward units within days, a manufacturing philosophy that prioritized quantity and supportability over individual performance. The war in Italy would continue for another 19 months, until German forces finally surrendered in May 1945. Throughout that fighting, American jeeps would be ubiquitous, carrying supplies through mountain passes, maintaining communications across broken terrain, evacuating wounded from positions no ambulance could reach. They would break down frequently, because crude, simple designs operating in harsh conditions do break down. But they would be repaired quickly, or replaced entirely, keeping Allied forces mobile while Axis forces struggled with lengthening supply lines and dwindling vehicle stocks. In the decades after the war, Italian automotive industry would be rebuilt with substantial American assistance through the Marshall Plan. Fiat, Lancia, Alfa Romeo would adopt many of the manufacturing philosophies that made the Jeep possible. Standardized components, interchangeable parts, production line assembly, design for manufacturability. The craft manufacturing traditions that had produced small numbers of sophisticated vehicles would gradually yield to mass production techniques that enabled Italy's post-war economic boom. Fiat would eventually produce its own Jeep-inspired vehicle, the Campagnola, introduced in 1951 for Italian military use. The Campagnola borrowed the Jeep's basic layout, lightweight, four-wheel drive, simple construction, military utility, but used a diesel engine because Italian industry had maintained its diesel expertise. It would serve Italian forces for decades, proof that Italian engineers had learned the lessons first observed in that captured American vehicle in Sicily. But perhaps the most significant legacy of the Jeep examination was philosophical rather than technical. Italian engineers like Morandi and Benedetti had been trained in a tradition that valued individual excellence, sophisticated solutions, and careful craftsmanship. The war taught them that sometimes the best solution is the simple one, that manufacturing philosophy can matter more than engineering elegance, and that sustained production capacity defeats technical sophistication. These lessons would reshape Italian manufacturing across all sectors. The post-war Italian automotive industry would become famous for producing affordable, practical vehicles in large quantities, Fiat Cinquecentos, Lancias, Alfa Romeos, that ordinary Italians could purchase and maintain. The pre-war emphasis on limited production vehicles, requiring specialized maintenance, gave way to mass-market products designed for owner serviceability. The suspension systems on these post-war vehicles reflected the Jeep's influence. Simple, robust, serviceable with basic tools. Not as sophisticated as German designs, not as refined as British designs, but practical, affordable, and adequate. Italian engineers had learned that adequate but producible beat excellent but limited in both warfare and commerce. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.